Hello, this is Mentor Sabrina, and in this video I will be going over modular arithmetic. Now, first, one thing I want to point out is that modular arithmetic goes hand in hand with division, specifically long division. So, if you have a number like 42, and you divide it by 4, then what you get here is 4 goes into 42 10 times with a remainder of 2. What modular arithmetic does is all it cares about is this value here, the remainder. The remainder is what modular arithmetic is solving for. Now, the way we would write this with modular arithmetic, with using the mod operator, would be like this. Where's my mouse? 42 mod 4 equals 2. Now, modular arithmetic is important for the rounding numbers, project, specifically because if you have a number like, let's say, 327, and you want to round to the nearest tens, so we want to round to this number, we have to look at this number. But in an integer, we can't just get that number. We have to use some sort of operation to find out what that number is. And that's where modular arithmetic helps. So what we would do here, since this is in the ones place, and we want to round to the tens place, we're basically just taking the invisible decimal point that's here and moving it over one space, and then finding out what's after the decimal. Well, when we're doing that, because this is in base 10, what we're really doing is we're taking this number and we're dividing it by 10. Now, when we divide 327 by 10, we get 32. Because we have 32 times 10, you put a 0 at the end of 32, and you get 320. And this gives us a remainder of 7. Notice that this remainder here is the same as this last digit. So depending on the place that you want to round it to, you can use modular arithmetic to get that number and then check if this number is greater than 5, greater than or equal to 5, and if it is, you round it up. If it isn't, you round it down. That's basically what we're using it for. Now, to point out, modular arithmetic is clock arithmetic. If you take a look at this, we're doing 1 divided by 4. We get, that's 0, because 4 goes into 1 0 times, with a remainder of 1. When we do 2 divided by 4, we get a remainder of 2. 3 divided by 4, we get a remainder of 3. But when we're dividing something that's evenly divided by this, we get a remainder of 0. And it starts over again. Remainder of 1, 2, 3, 0. If you think of it, it's kind of like binary. If you know a binary number is ones and zeros, it's all 1 0 1 1 0 and so on. Well, that's because it's base 2. If you divide it by 2, whatever the number is, you'll get a remainder of 1 or 0. And that's how how binary works. That's how our current base system works. You divide by 10. If it's evenly divided, there's no remainder. It's a remainder of 0. But add 1 to it, and you have a remainder of 1. That is basically what you need to know about modular arithmetic. In the next video, I'll show you how we do it with code.